Welcome to today's lecture. Today we'll be talking about epidemiological study design. So this particular lecture has been broken into two parts. So this is part one, and we'll come to part two. But we'll also look at part three, which relates to controlled clinical trials. So we have this introductory lecture, and then we'll go to looking at more into details on experimental studies and observational studies, and then we'll zero in looking at clinical trials or controlled clinical trials in part three. So the objective of the lessons are as follows. I want you to appreciate the importance of a study design in a scientific inquiry. So what is the importance? Why should one have a study design when undertaking a scientific inquiry? And also at the end of this lesson, you must be able to describe the various study designs, their assumptions, advantages and disadvantages. So what are the various study designs that a person can apply to undertake a scientific inquiry, and what are the underlying assumptions for such study designs, and what are the advantages and disadvantages of each of these study designs. So that's what we'll be looking at. Also want to appreciate the issue of internal and external validity and the impact of intrinsic and extrinsic factors on the validity of research designs. So this is what we'll be considering. So I want you to be able, at the end of this lecture, to appreciate this. As you know by now, that epidemiology is the study of distribution and determinants of the frequency of health events in populations, and also the application of this study to control health problems. So epidemiology is a scientific discipline, that has sound methods of making scientific inquiry. So that is the foundation of epidemiology. It's based on sound methods of conducting scientific inquiry. And it's majorly data-driven and lies on systematic and biased approach to correction, analysis, and interpretation of data. So that is the key principles that govern epidemiology. It's a scientific discipline, and it provides sound methods for making scientific inquiry, and it's also data-driven and lies on systematic and biased approach to correction, analysis, and interpretation of data, of course, which should lead to control of health problems. So if you look at the research process, basically these are the key steps that are involved in a research process. So you have identification of a problem, that you ask a question and do background search, construct a hypothesis, test your hypothesis by doing an experiment or making observation. You analyze your data and draw a conclusion, then communicate your results. So this is the research process, or the different steps that are involved when you are making a scientific inquiry. So you see that when you have an hypothesis or you have a research question, the next thing, of course, is to test the hypothesis by conducting an experiment or making certain observations. So now, how do you do that? So in epidemiology, we are saying that you must do this systematically and also without bias, so that you can test your hypothesis correctly, and also this improves, of course, the validity of your finding. So a study design in this context will allow you to make sure that, of course, you do your literature search well with proper literature review, but it will also help you that you understand clearly the research problems and also formulate hypotheses. So these three mentioned here are very important for you to make sure that you understand the type of study design that you are going to use. So if you haven't done proper literature search, and you are not focused, you don't know what you are going to, your target of your question. If your question, for instance, is not focused, it will be very difficult for you to choose which study design to adopt. So this is very, very important. And of course, the hypothesis must be clearly and concisely formulated so that you can choose the right pattern for collecting disease. If you ask a wrong question or you make a wrong hypothesis, it will be difficult for you to, move, in the right direction in terms of, collecting data and providing answers to your question. So a research design is a plan specifying how you intend to fulfill the goals of your study. That is providing an answer to your question, your research question, or testing your hypothesis. So they provide you with a plan to use when collecting data, analyzing and interpreting data with respect to the question that you want to ask. So it gives you a plan how you are going to go about it. It gives you the steps that you need to take in order to go about providing answers to the research problem that you want to handle. So research design contributes to systematic observation so that things are not done haphazardly. So you are systematic. You follow well-connected steps, which are all trying to lead you to answering your research problems. But it also helps you to make sure that your findings are valid, because you can spend time collecting data, analyzing and interpreting it, but then your findings could not be significant, or they could be heavily biased. So research design will help you to reduce bias, in your conduct of a study, which will lead you to collect more valid results. So we've been saying that the purpose of the study, as I've been saying, I think this is much more also provided in the previous study. In the slide, it suggests the necessary observations you need to make to provide answers to your research question. So it will provide you with the necessary observations you need to make in order to answer the question, and also outlines the ways you should make to make observation and identify analytical and statistical procedures you need to do when using analysis. So basically this has been also spoken of in the previous slide. So when you look at research questions, basically they will fall into two major categories. There are questions that will hinge on existence, and also others which will hinge on causal. So existence question will often start with when, where, but causal questions will begin with how and why. So they are causal. They're trying to see why things happen or what could have caused. So a major purpose of epidemiological research is to establish that the independent and independent variables are causally related. So you find that most of the studies that we do, we want to investigate the relationship between two variables. That's the independent variable and the dependent variable. We want to see whether these are causally related. So what are the factors that will affect the choice of your study designs? So there are certain things that will affect for you to choose a particular design against the other. One of the things that will affect your choice is the purpose for your investigation. Is it to explore and describe some natural phenomena, or do you also want to explain what you have discovered, or do you want to pursue both purposes? And also the other factors that will affect the choice of your design are the necessary data readily available. The data that you are trying to collect, is it legally available? We are talking about issues of feasibility here. Are they necessary data available? How about time? Do you have sufficient time, or do you have limited time to do your study? about financial limitations. And you also require a control group if you are to test your hypothesis or answer your research question. So these factors will help you to decide which study design may be appropriate in your case. There are also threats concerning the internal and external validity of your findings. So these factors are important. You realize that some study designs have good internal validity, while others they have enhanced external validity. So depending upon your research question or your hypothesis, you may want to settle, for instance, for a study which has got high internal validity or a study which has high external validity. We'll look at this when we look at specific study designs. So validity refers to how good what we are measuring does at predicting or explaining what will happen outside our controlled environment. So how well is our results, or what you are measuring, how well are we to predict what could happen outside the controlled environments? So they are often divided into two. We talk about the internal validity. Internal validity has to do with the confidence we have in the causal relationship between the design and the outcome. In this case, for instance, if I'm trying to test whether a particular factor affects one outcome in a controlled environment, for instance, if it works well, then of course it has to do with settings as done in the lab, for instance. So that has to do with internal validity. So how well the factor, correctly predict the outcome. So that has to do with internal validity. But when it comes to external validity, the results that you got in the lab with high internal validity, but you find that when you take it to the real world, things may be different. So with external validity is how well can we extrapolate our findings to the real world. So you find that studies that in which the findings can be well extrapolated to the real world, those have got high external validity. Whereas the studies, where the causal relationship between the outcome and the predictor variable, is correctly predicted, those have got high internal validity. So the selection of one design over another depends on the particular research question, say the type of research question that you have, the concerns about validity. Are you interested more with the internal validity or external validity? And also the efficiency, how efficiently do you want to collect data, and also the practicalities. We talked about feasibilities, talk about the time that you have, talked about the resource that you have, and also ethical considerations. You see that there are certain studies that could be ethically challenging to do, whereas others, they have little ethical consideration. So you have to look at those. So there are several types of study designs, but majorly they are broken down into two. That's experimental and observational studies. And so, as I mentioned earlier on, that an epidemiological study design or a study design, it simply represents the different ways of collecting information. So these are patterns or methods. We are saying that the epidemiology is the study of disease patterns in populations and the determinants of such. So now, if you want to study or investigate the disease patterns, if you want to investigate the risk factors or determinants of those diseases, you need to collect information from those populations. But now, how do you go about collecting that information? You apply study designs. So this is basically the framework, if you like, at the different types of study designs. So we have in two broad categories: analytical study designs and descriptive. When it comes to analytical, we have experimental and non-experimental. Non-experimental, also we call them observational studies. And under observational studies, we have got a cohort study, case control, And then you have the case cohort, case control, and cross-sectional studies. And an experimental study, we have randomized clinical trials and also non-randomized clinical trials. So the randomized clinical trials are often used, and is the matter of our consideration in the third part of this series of lectures. Of course, we talked about descriptive studies. They are also important for the appropriate questions or hypotheses. So I mentioned earlier on that there are two main broad categories of study designs: observational studies and experimental studies. And the major difference or the major characteristic of observational studies is that in an observational study, the researcher identifies subjects. For instance, if you want to see, your question, your research question is, for instance, what is the major breed of animals in Lusaka, for instance? What is the major breed of cattle in Lusaka? So you have identified your subject. Your subject is cattle, and you want to check for the breed. And so all you do is you move around farms and observe, the frequency of these breeds in the farms. And then when you observe, you record. So that's an observational study. So you identify your subject, cattle, you observe the breed, and you record. Whereas in an experimental study, something else happens. You identify your subject. In an experimental study, for instance, this you may want to find. You may want to see the relationship between the factor and the outcome of interest. For instance, you may want to say how effective is chloroquine in curing or treating malaria. So you have chloroquine and you have malaria. And so what you do is that you identify your subjects, people with malaria, and then you put them in common context. And you remember that we said that there are certain studies that will need a control. And in this case, experimental studies always requires a control. So you have a group which will receive the treatment of interest, in this case malaria, and then you need to have a control group, the control which will not receive the product of interest. In this case, we may give other drug which you may need to compare with. And when you identify your subject, people with malaria, you put them in common context, you balance the groups. The control and the treatment group, must be balanced so that, any results observed will not be attributed to any other thing other than the treatment that has been given. So you put them in common context. If it's the age, you balance the age. Sex, you balance sex, so that group A and B are balanced groups. And so that whatever observed will be attributed to the factor that we're investigating. And then you, after putting them in common context, you apply the intervention. You apply the treatment. You give them treatment. So you see that that step is omitted here, but it should be the third step. The third step is apply treatment or apply the intervention. So in this case, you administer the treatment. You administer chloroquine. And then after that, you observe what happens after treatment. Is the temperature going down? Or, is the parastemia going down? So you observe that, and then you record. So basically, that's the overview of the characteristic of the observational and experimental studies. So in experimental study, investigator has a role. He intervenes, he manipulates. So as opposed to the observational study, where the researcher simply observes things as they are in nature, in this case, the experimental study, the investigator intervenes or does some manipulations. And in this case, what you are saying, the example that I gave regarding the testing for efficacy of malaria treatment, the researcher intervenes, and the intervention is doing is that he's administering the drug to one group and and maybe a control or a placebo to the other group. So that is an important aspect of a treatment of experimental study designs. And this type of study designs, are described to be scientifically to produce scientifically rigorous data of all study designs. So the studies, the data that is generated from this, has high internal validity. And that's why these study designs can be used to establish causation. Broadly speaking, experimental studies can be broken down into these three. That is the preventive or prophylactic trial. So these type of experimental studies, they investigate a measure that prevents occurrence of disease. So, for instance, if we are doing a vaccine trial, so such a trial, such a study will be a preventive or prophylactic trial, because we are trying to see the efficiency or the efficacy of this particular vaccine. The others are therapeutic or clinical trial, where the investigator is trying to see how effective the treatment the treatment is, in making this case. So they investigate. So therapeutic trials are used to investigate how effective a particular product is, in treating. So in this case, the example I gave in the malaria treatment using chloroquine, that is a therapeutic trial. In the disease causation trial, these investigate whether a particular agent is responsible for causing a particular condition or disease outcome. So this is a kind of trial. For instance, if you want to see whether pathogen A causes a particular condition, then trials are done in the labs to see whether that is a response. So that is a disease causation trial. Whereas the observational trials are natural experiments. As I said, the investigator simply observes what is happening in nature, and then records. So these are, in most cases, they are ethical to do, and they are normally feasible because they tend to be cheap. So this is an overview of the different types of studies, epidemiological studies. Talked about the experimental studies, and also talk about the observational studies. Under observational studies, we have the cohort study, case control study, and the cross-sectional study. But we also talk about the ecological study. So in experimental study, it studies prevention and treatment of disease. The investigator actively manipulates which group receives the agent under study. Whereas in an observational study, this study studies causes, prevention, and treatment of disease. Investigator passively observes as nature takes its course. So it doesn't actively manipulate, but passively observes. Then you have the different types. The cohort typically examines multiple health effects of an exposure. So subjects are defined according to their exposure levels, such as exposed, not exposed, and then they are followed up for occurrence of the outcome of interest. And then in a case control study, it typically examines multiple exposure in relation to disease. So subjects are defined as cases or controls, and exposure histories are compared. So in this case, in a case control study, we identify cases and we identify controls. Then we look back in history to see whether they are exposed. Then we have case control, cross-sectional study. It examines relationship between exposure and disease prevalence in a defined population at a single point in time. We'll come back to this later. And the ecological study examines relationship between exposure and disease with population level rather than individual level. So when we're talking about ecological study, these exposure levels are assessed at population level, not individual level. So what is the take-home message? We are saying that a research design is a plan specifying how you intend to fulfill the goals of your study. There are several types of study designs, including experimental studies and also observational studies. Each type of epidemiological study design simply represents a different way of harvesting information. And selecting of one design over another depends on the particular research question, concerns about validity and efficacy, and practical and ethical considerations. Thank you for listening.